Here. Well. So now, figure out how to. When you want to express the formula, is you use. For example, I'm going to boy at a minute. I'm going to. So let's fill out our. Okay. No. Make sure to put. It's going to be the verb be in this. Okay, so number one, boy. Notice it follows and then go back. So what do you think number one says? Yo voy a tocar el piano el lunes. What does it say? Boy. Oh, oh. Yeah, they have a bit what is that? Or hamburger. Then it would be. These people like how to be that are going to live a life. And also, even though the margin problem. Yeah, because you know the dogs. For margins. Not well, I mean. All right, number 6. Who played ice skating at the Classic? You are going to.
Good morning. How you doing?
Good.
All right.
But how I in that. Yeah. You're gonna call this, I'm gonna say, you're gonna call off a long time. Yeah. Yeah, it is. It means two, right? You know, you can go play private, finance, and paper. Well, wow. Beautiful, my family. Yeah. Your and you are going to. This place, this.
Where's half your class this morning?
Start dry.
They're all hiding, or they got stuck in that terrible crap out there. Yep, it's pretty bad.
Oh, yeah.
Traffic is really bad. Because they are busy trying to make the roads better, but in the meantime, they're gonna make it worse, so. Needs for you too. That's good. There you go. Make sure I don't have any messages from anybody saying they're not coming or something. I don't see any.
All right. So three little. Pick out 3 and any numbers.
Hey there. Here's one. Hey, what's up? Is it Eunice? You good? Yeah.
Miss Danny?
Yes, sir.
I have lots of brownie points. I don't know how.
Really? Okay. You'll have to tell me.
Okay.
I have one that I caught today before anybody else. It's in today's lab. There's a P missing from the word ramp the second time I wrote it. I think it's the second time. You're fine. It's traffic. It's terrible.
I woke up 25 minutes ago.
Okay. Thanks for giving those images. I don't like to do it.
Good deal.
So the answer,
Oh, look at this. Here, I'll take it. Let me see.
look
Look at it. He wrote them all down.
the
Outstanding.
interesting was like on the binder on the lab.
Yeah, the only one in the lab that I caught was the ramp,
Oh
but
my
yeah.
God, yes.
I haven't gone to cooking today. And I don't know. I haven't had it.
It's-
Determination time.
You're good. All right, so we're gonna be continuing our forces in motion today.
Are we gonna learn about gravity and friction?
A little bit. All right, so let's see. We're gonna be getting to more and more of it over these next couple weeks, but it should be fun. I guess Emma's wherever Emma is. Traffic is wonky. I'll give you guys a heads up. I've been having dizzy mornings with my lupus, so today I'm a little like, so if I sit down for a minute or if I go, hold on, it's just trying to gather myself. So I know it's not in the least bit hot in this room, but like I'm sweating and stuff, and that's just me. That's what happens when your body hates itself and tries to attack itself for fun, which is what mine does. So fun times. All right, so forces in motion continued, right? As we started last week. There's my little Newton rat. He's so cute. He's my favorite. One of my little Newton rats.
Miss Danny.
Yes.
I forgot to color Rico.
That's okay. You did last week, so put it up there.
And before we start,
Mm-hmm.
me and Lewis are not going to be in the class next week because we're going to be on vacation.
Cool. All right. Well, you know what to do. You can either tune in live or watch it later and comment on the video, right? All right. So friction. This is probably one of my favorite AI generated images yet. I mean, come on. Look at that. Anybody ever gone down a slide like that? You know how it feels.
Oh, and then
Yeah.
static to your hair.
Yeah. Oh, really? Really?
He's there, and he just went.
Yeah. Yeah.
Yeah, so you do that, and when you get up, you touch something, and it goes like
Zap. Yep. So here we've got some friction. I like her. She's going face down in her little party dress, but she has sort of I don't know, somehow there's an expression on her face that looks like, I don't know why, but her eyes are real big. Maybe that's it. So what is friction? So what do we call that force? All right, Carlos, that opposes the motion of objects as they touch or pass each other. Wait a minute, he's looking. Force that opposes the motion of objects as they touch or as they move past each other. You got it. It's the easiest one. It's the whole point of the lesson. You got it. Yeah, friction. All right, there you go. Friction. All right, so all moving objects are subject to friction. There are 4 main types, and we're going to go over them here in just a second. So this dude hanging out on a swing, different types of friction would definitely be at play, right? If you sit on a swing, you've got the friction keeping your butt stuck to the swing, right? And then there's also friction from air, which we're going to talk about. So what do you call the kind of friction that acts on objects that are not moving, Darcy?
Oh my gosh. When I'm what friction?
Not
gravity.
Not gravity causes it.
Mm.
Eunice, do you know? Static friction. Okay. Static means like not moving. Okay. So something can be you think of static electricity, right? Which you actually get from you think about moving your hands and zap and stuff, right? Well, static friction is what happens when things are not moving. So there's actually an entire study of engineering called statics. And it was my husband's least favorite engineering class. He hated it. It was really, really hard. And he likes hard things, but he didn't like that one. I remember him telling me every day, as soon as I get out of the statics class, I'm going to celebrate. So
These are hard.
hard things are hard, right? And engineering is a very challenging degree. To get a degree in engineering is a lot of work. So yeah. So in this case, this little rat is sitting flat on the floor and, the earth's moving. What's keeping her from just flying along? Well, friction. It's on her little rear end there. So what do you call the kind of friction that opposes direction of motion as an object slides? Nico, the sliding friction. All right. So here she is ice skating. Anybody been ice skating? Who's been? I've been. Yep.
I'm actually pretty good at it.
it's fun. I thought maybe I'm good at it. It's fun.
5 or 6 times I've done.
There's a lot of reduced friction, right? The friction's reduced because the ice allows you to slide along, right?
I can't wait to go this year because I'm trying to learn how to skate backwards.
So when you take, when you're wearing an ice skate, you got that blade, right? that blade presses down with all of your body weight into that ice. And the increased pressure actually causes for a physical change in that composition of the ice and causes it to melt a little bit. And as it melts, you get a thin layer of water under your blade. And that makes it real easy for you to just slide along, right? And then what do they do when the ice is all scratched up? Anybody ever been to a hockey game?
yeah.
And Lewis, what do they do?
They have this machine that,
Football.
oh, I like,
It's got the best name. Do you know what it's called? Does anybody know what it's called?
I remember the first 2 letters of the name, but I can't remember.
What is
the
it?
one. I think it starts with an F or a D.
It's called a Zamboni.
A Zamboni.
Yeah, and the Zamboni comes
love-
out, right?
I love
Zamboni.
Mhm.
the rim when it's
Right after the
freshly-
Zamboni went,
freshly-
and it comes and it makes that nice, perfect sheet. It's so much fun to watch the Zamboni if
And then
you go
you
to a
take
game.
off your ice skates and you have blisters.
Yeah. So my nephew plays ice hockey and he's actually really good. Like he's on a travel team and he's trying to get into a school to play ice hockey for college, which is very difficult because they usually only recruit out of schools in the Northeast where hockey is more common, or schools that are like boarding schools. So he's been looking at it. He's serious about it. That kid can skate, let me tell you. You know who else is a skater and plays hockey is Liam. Liam plays goalie for competitive hockey team. So you could talk to him about sliding friction. All right. And then what kind of friction acts on rolling objects? Okay, Lewis.
Rolling friction.
Rolling friction, obviously. All right. Is anybody successful at skateboarding in here? You can do it?
Well,
Can you do it?
I can do longboard.
Oh, wow. Yeah. Can you do it?
My friend's house.
You did? Could you stand up and actually do it?
I can do it. It's about 10 seconds and it fell down.
So she's missing a few things to be skateboarding. What's she missing?
Feet.
Well, I'm assuming her feet are under her skirt.
A helmet.
Yeah, she needs a helmet and knee and elbow pads for sure.
A ripstick, one of those things.
Yeah.
I am really good on that.
Are you? Oh my God, I can't stand up, y'all. My best friend had a skateboard when we were kids, and the most I could do was sit on it at the top of the driveway and ride down to the bottom. That was as good as I could do. Like I was not, but see, where I grew up in Virginia Beach, a lot of people were surfers, right? And surfing and skateboarding are not all that different when it comes to like how you move your body and how you shift your weight and balance. So we had a lot of skateboarders when I went to high school. It was like a super popular thing to do too. And there were city parks that had like the big skateboarding ramps and stuff. Anybody been over to, what is it? It's the Fowler Park. You been to this? Have you seen the skateboarding pools there? No, they might have one at Hall Creek too, but I know at Fowler Park, they have pools.
Yeah, they have one in Johnson Creek as well.
So people do that. People have swimming pools and they don't want to swim like back in the 80s, especially in the 90s when it was real popular. You would just drain your swimming pool and then you just skate in it. So that was a thing. And so they built some pools and some ramps over at Fowler Park. So if you ever want to give it a try, it's a great place to go. You can really let gravity act because there's lots of.
I go with my scooter.
We
Yeah?
take scooters. Oh, when it hits you on the shin.
Mhm. Did you? Yeah, it's nice over there. It's a good place to be. And yeah, it's I wish I could. I tried to skate. Actually, the new things are, so anybody been in a city recently, either Atlanta or any other city,
Yeah.
and seen the scooters that you rent?
Oh yeah.
Like Bird or,
We have those.
yeah, yeah, do you?
Yeah.
It's just 20 miles an hour. It's just fleeing around.
So I tried one a couple of weeks back and I got off immediately and told my husband, this isn't good. I'm gonna die. So I'm getting off now because I know that I'm gonna get hurt. I can tell right now. And let me tell you, when you hit about 30, 35
I love that.
and you get hurt, it's real bad. No, I mean 30, 35 years old. When you fall, it's like the end of the world. Like you guys fall and it's like, and you get up.
I thought
Something happens.
this was an electric scooter crash.
Something happens when you're 30, 35 years old that makes every injury like 1,000 times worse. And so I was like, no, I'm not doing this. Like, I know my balance gets funky, lupusy stuff. So I got off. But I saw an ER nurse the other day who made a video on social media and she was like, for God's sakes, don't use these things. Like she's seen people with head injuries, cracked skulls, because people don't have a helmet, right? Because they just get on them because they're just going one
Oh, like how I see the kids do this. My mom
Mhm.
once went on a hoverboard and she
Oh.
started twisting around and around. She's like, oh, they can do it. This is easy.
Yeah.
and she left a dent from her nose.
Yeah,
in
believe it.
our chair.
I believe it.
And her friend literally almost broke her back doing it.
Those are crazy. What do you want to say, Lewis?
Yesterday or the day before,
Mhm.
one of my friends went to the Falcons game,
Oh, yeah.
and his grandpa fell off a curb and broke his arm and has
Brandon.
Wow.
Yeah.
Speaking of rolling friction, so my husband's a cyclist, right? So I hear all kinds of cycling stories. Yeah, actually, we need to get them together.
Professional cyclist.
We need to get them together.
Yeah.
Truly. So, because my husband could use, where are you guys now? Where's your new house?
River Club.
Oh, yeah.
Swan.
Okay. Yeah. So, yeah, his cycling partner moved like up to Dahlonega or Dawsonville. So they only cycle together on the weekends, but they'll do like a 40-mile, 30-mile thing, but he needs somebody during the week. We should hook him up with your dad. But anyway, I was going to say, so I hear all kinds of cycling stories, but I heard last week, my friend Inquire told me her mother-in-law was riding her bike. Her mother-in-law is like in her late 70s and has dementia and probably shouldn't be out riding her bike, but she was riding her bike and she broke her hip. She fell off and broke her hip. And she said and she was talking and, oh, thank you to these nice young men who helped pick me up and took care of me on the side of the road on the phone with her, like, all fine. Oh, I'm great. But, they took the x-ray of her hip. The whole ball at the top of her femur was crushed into her whole pelvis, just crushed. And they were like, give her the stuff you give people on the battlefield. Like, this is horrid. And she was like, oh, it's fine. So those people are built from different stuff. All right. And what do you call the kind of friction that opposes motion through a fluid? All right, Carlos, what you got? This is fluid friction. And we have different types of fluid friction. So when you think of a fluid, what do you think of? Water. Mhm.
Gas.
Or a gas. There you go. So anything that water and gas, liquid and gas are both fluids. So in most cases, rules that apply to liquids and how they interact mechanically are going to also apply to gases, like pressure and things like that. They're going to be very, very similar. But it depends truly on the type of fluid, the density of the fluid. Like, obviously gas is a way less dense fluid than, say, oil or water, which is even more dense, right? So there are different types, and one of those types, when you're dealing with air, what do we call that one, Darcy?
You call it oh my goodness.
You're good.
I thought I knew it.
That's okay. Lewis, what you got? Oh, now she sees it. What is it?
Free fall?
Air resistance. Okay, so fluid friction when you're through air specifically is air resistance, right? So this is why compare the way a race car is shaped to the way a school bus is shaped and think about their purposes. What's the purpose of a race car? Go fast. So why aerodynamic, right? What does that mean?
It means it can go through
Go ahead.
the air easier.
Easier. Yeah. How do you mean? Like what makes it easier?
More streamlined.
Mhm.
Like the shape of it.
Mhm. So think of it in terms of friction. What would be the difference between like a race car and a school bus front end?
The race car is more down, which is more downforce.
That's true. That's part of it. How about the shape of the front of a race car?
It's like almost like the ground. The bullet.
It's like a bullet or a wedge, right? Right. It's shaped so that the smallest possible surface area in the front is contacting that wall of air, right? Because that's friction. So as school bus is driving along that, get that flat front end. How about a MARTA bus? They're totally flat in the front, right? They don't even
That's
have a
how
hood.
the buses are in the UK.
Yeah.
They're just flat.
They're flat. So it's driving along and it's flat. All that surface area is coming in contact with all that air resistance, all that fluid friction with the air. So it has to combat all of that. But the bus doesn't care. It's not racing, right? But a race car, you want the smallest possible surface area to contact that wall of air, and then you're gonna cut through that fluid. And yes, they are pointed the angle down so that more of the fluid goes over the top, and that does push the vehicle down, which is what you want. Yep, that gives it better grip on the road. Yeah, and that's better rolling friction, right? Where the tires contact the road. Do you know why you ever watched race cars do burnouts before they race? Why do they do it?
They do it to get more. So like basically, if you're on a starting grid,
Mm-hmm.
it's 20 drivers in your third.
Yeah,
The mechanics sometimes roll the car backwards.
yeah, they do.
And the race cars spin their wheels
Mhm.
to get more traction from where they are.
Yeah, that's big. Do you know anything else about it?
To heat their tires.
So
Ah,
they can stick better.
so why are they heating their tires, Nico? What's the purpose of that?
Because
So think about rubber. So there's a couple things. So rubber expands when it gets warm, right?
yeah.
That's why, but it's also flexible. You ever notice like the little kind of rubbery strips in the road that you ride over when you're riding over them, right?
Oh yeah.
And that's because the concrete expands too. And those take that pressure when the concrete expands. Otherwise, it would just crack. The concrete would crack because it would have nowhere to go. So, but that expands too. And sometimes you can see them, they stick up out of the road. And that's why you hear it when you ride over it. Click, click, click. So that rubber is going to expand on the tires just a little bit, but enough. And it also becomes somewhat more fluid. It's more rigid when it's cold. And when you warm it up, all those molecules kind of move a little more and it helps it grip the asphalt. So when you see them burn out before they actually start to go, when they're burning out, they're just doing that because they're really heating up those tires so they grip better. And it's does anybody know how you burn out a car with a stick shift versus a car with an automatic transmission?
You don't press the
You
clutch.
know? How do you know?
Stick shift.
Yeah.
It's easier for you to like drift around
Yeah.
and like go change
Mhm,
directions way faster. And automatic cars, it's not as easy.
It's not as easy. Yeah. So if you're gonna do a burnout in a stick shift, and I never told you this, if you're gonna do a burnout in a stick shift, you make sure you're somewhere where you are on level ground, because if you're gonna take both of your feet are gonna be active, so nothing on the brake, unless you've got an emergency brake that's really dependable.
Yeah.
But you want to put your clutch weight to the floor, and then you put your gas weight to the floor. Now your engine's torque is at full and it's revving. You can see your little RPM thing go up on the tachometer. And then when you lift your foot off the clutch, it'll spin the tires and you'll go. With an automatic, you don't have a clutch. So it's called a line lock, and it actually locks the brakes on the front of the car, and it allows you to spin your rear tires out, and then you can like click the button and then you'll move. I have a line lock on the Mustang, but Cole wanted it, so we put it in, and we have video of him trying to burn out in the church parking lot, because I was like, let's go somewhere where we won't get a ticket. Church parking lot. All right, so types of friction. Did you have a question first, Lewis?
Yeah, so there's this sport called Formula One.
Yeah. Mhm.
Those cars are basically like 8 millimeters off the ground.
Yeah, they're really low.
Yeah, and the tilting on the front wings like that.
Very high, because it pushes them down. That's what a spoiler on the back of a car does too. If you ever seen a spoiler on somebody's trunk, it also pushes them down. All right, so types of friction. This is a review of what we just went over.
Introduction. This is a pool table.
Thanks.
When the ball is hit, it moves to a certain distance and slowly comes to halt. How and why does this happen? Let's start the lesson and find answers to such questions. Objectives. At the end of this lesson, you will be able to define friction, illustrate smooth and rough surfaces, describe the types of friction, discuss advantages and disadvantages of friction, illustrate the way to reduce or increase the friction. Let's take an example from daily life. While moving on a bicycle on the road, you pedal the bicycle and it moves on and on. When you stop pedaling, the bicycle slows down and gradually comes to a stop. Why does this happen? This actually happens because of friction. Friction is a force that is created whenever two surfaces move or try to move across each other. Friction always opposes the motion or attempted motion of one surface across another surface. The force which resists the motion of a body while moving on a surface is called friction. Friction is dependent on the texture of both surfaces. Friction is also dependent on the amount of contact force pushing the two surfaces together. A simple answer to this is that while in motion, the tires of the bicycle are rubbing against the surface of the road. When two surfaces rub on one another, the force comes into play. This force acts in the direction opposite to the direction of motion. Thus, it slows down the motion and finally brings the moving object to a stop. In figure, a ball is rolled on smooth surface and another similar ball on rough surface. As you see here that both the balls starts rolling on different surfaces with same speed, same force, and at same time. But the ball which is rolling on smooth surface travels a larger distance than the ball.
Don't know why the
rolling on
video
rough
and the
surface.
audio don't quite line up. But
This
whatever.
shows that the rough surfaces offer more friction than smooth surfaces for the same pair of contact surfaces. This
You can't
example
push, man.
proves that friction depends on the texture of contact surfaces. It is interesting to learn that friction depends on the amount of contact force pushing the two surfaces together. Let us find out.
Let's
Here,
find
a
out.
man is trying to push a heavy box.
He already did that.
The box is not moving. Have you any idea why this happens? Well,
Friction.
when the box is pushed, the bottom of the box and the floor rub one another, and friction comes into play, which resists the motion. The force from friction is more than the push force being exerted by the man. The box will move only when a greater force than the force from friction is applied on the box.
Hold on, let me pause it
Once
for like
the bo-
5 seconds and see if it catches up, because that's really weird. Like, that's a strange YouTube event. All right, try again.
box starts sliding. You may find it easier to move the box.
Well,
forward
pretend he's
enough.
pushing the box still.
This example proves that friction depends on the amount of contact force pushing the two surfaces together. Now we can easily define force of friction. The force of friction is a force which opposes the motion of a body.
Oh, we're at the summary,
with
but we're
contact
not.
with the surface of another
But
body.
we are.
It acts on both the surfaces.
Fun.
Some surfaces are smooth and some are rough. Some are less rough and some are more rough. Even a smooth surface has some irregularities, roughness on it. For
Oh,
example,
look at that.
when
He's
we
still
try to move
talking.
one sandpaper over the other, the movement is not
Look
smooth.
at that.
That means there is friction.
Well,
due to
that's
the
bizarre.
interlocking of rough surface.
I don't think it was like that when I looked at it initially. But you get the point. No, that's YouTube, because you can see where the space is, like it hasn't lined up. Oh, now it wants to be fun. Right, go to the next one. There we go. Gravity. There we go. All right, gravity. I love her. She's probably my second favorite of all these. I don't know how she got floating like that, but she's cute. So gravity. Gravity is the force that acts between any what?
Surface.
What? Oh, I didn't hear. Oh, Lewis.
Surface.
Between any surface? Anybody else have a different answer? Darcy?
Between any
Nico, you had it.
object.
Yeah, between any two objects, okay? Any two masses or any two objects, okay? So Earth's gravity acts in what direction do we say? Eunice?
Downward.
Yeah, downward from our perspective. So we say downward, right? But obviously if we were in space, it may not be downward. It kind of depends on what downward is for you, right? Acts downward towards the center of the earth is absolutely right. Towards the center of the earth. The reason that you have gravity acting between any two objects. So any two objects, this object and this object, this object and this object. But the reason that you can see it with Earth so well is that Earth is just so big. That's what it is. So this guy, this I hope works, because this is my favorite visualization of gravity ever. It's super cool. Hang on one second though. Let me see. Hang on, I just want to make sure I know. Yeah, okay. This is cool. Hopefully it will play correctly, because it is really neat. This guy's a teacher teaching other teachers like how to do a lesson. He's giving them a lesson idea. Okay, come back here.
What?
All right, internet, don't screw this one up. This is like my favorite video for gravity. Load, load, load. So anyway, sometimes teachers go to conferences where they learn how to teach. And that's what this is. This guy is,
My friend's mom.
mhm. Yeah, you teach teachers. I will open it in, unless it's gonna play right this minute. Yeah, I don't know why it's doing that. So I will go over, as soon as I hit that, it went, here we go. Nope, maybe not. Really? Be like that.
Teachers.
I will put it over here. Hopefully we won't have that here. Teaches teachers about teachers.
Teaching teachers.
Yep. Because teachers in like public schools and even in private schools, they have to have accreditation, which means they have to do certain classes to keep their teaching license. So that's kind of what this is. This guy, all right, hopefully this will play now because it's not within PowerPoint. Either that or the internet just died.
My daughter.
Oh, now we got to watch a commercial, which is a sad one. We have to watch a commercial since we're not in PowerPoint. All right, that makes me sad. Let's skip that for now. Okay.
The explanation for gravity is that matter bends space. But mass in place space, work space time, and objects are not.
Come on.
Force of gravity that is following the axis of curvature. This is the sheet. I don't know where you get this. My old bike. There's literally a spandex.com. You can get a sheet like this.
I love it.
Sales stuff, so you don't care what it looks like, right?
Trying to make it bigger, but it doesn't want to go.
Got 6 minutes now.
Yeah, and it's not supposed to be, so it's being very strange. What is going on, internet? Wow, boy, internet is confusing today.
Oh, it's not 9 minutes. Okay, so just put a thing on it.
Sun move a little bit, so far you can ignore it. When the moon makes the earth kind of
Hey.
wobble around the point three.
Here he is. Maybe. What the heck?
Oh my goodness.
For like $20.
There we go.
West on and so you put matter and it works space time. And so if I have another object, it also works space time. They feel that and they're attracted to each other. And so that's Einstein's picture of gravity. Objects work space time, feel like they're move. Yeah, more. Right. Yeah, more to then space time more. And so you have a lot of it together.
That a room?
Now, in reality, that big mass would feel the work in the space time of the marble too, right? And we move a little bit, and we usually ignore that. You know, the Earth makes the sun move a little bit, but it's still small, you can ignore it. The moon makes the Earth kind of wobble around the point 3/4 away from the center of the Earth. We usually don't account for that when we look at Saturday. Well, instead of just letting go of one, what if I did a side loop? Now it orbits. Now it's losing energy, which wouldn't happen in the solar system, right? Not noticeably. There's perturbation from other planets and things, but this one does lose energy fire then. If I don't push it as hard, it will do an ellipse. Wow. So one of the things that I thought I would do is this. If we study the solar system.
He keeps stepping out of grabbing marbles and balls. So why is everything orbiting the same direction in the solar system?
It wasn't.
Oh my gosh.
But it was a preferred direction. It formed from here.
You guys move without marbles.
Everything's going to sit. That was 90% of the time. Maybe not again. And so,
So cool, though.
Slightly more money. You wanna get it spread out a little.
Now it look like fun.
The ones going up the wrong way get eliminated. Now, there also would have been, this is where this analogy breaks down, is another dimension, right? But those things are out of the plane also, that weren't near the preferred plane also does. And so that's kind of cool. Now, my students use a PhD set simulation called My Solar System. And so they've seen all this on the computer. And when we do this during our special relativity unit, they're like, hey, it's just like the computer. It's kind of cool that a stretch sheet of light models things synthesized, different, but similar to the computer. Now, some things we discovered using this, all that is some larger marbles, try to put them out, but they bend space-time too, right? And so maybe.
You see what's going on?
I can't tell.
That little one is orbiting the big one. See it? Look. See it going around it?
I can't tell if those are magnets, some of them.
No, they're just marbles and balls, steel balls and marbles.
And so you see that this theme, you can't buy micro this big. You get it in rolls, and you have to sew it together. I've been told to use stretchy string, stretchy thread to sew it together. And so next time I do it, I'll do that because it pulls. And so you just a little bit of thread fixes it. And so in the morning, when I first put this up, was meeting against the table underneath fixed balls from last year. One time my principal walked in. And I hear somebody in the room, and I'm underneath, I'm in the middle of sewing in, I have to pause there. And then he's looking around to me, and he kind of knows somebody's in the room. He's, oh, there you are. He goes, what are you doing there? I go, I'm repairing a rip in the fabric of space-time.
Are you gonna bother me now?
So he does some more things too that are also interesting, but this video is that man, no, okay. This is also in your you know how I give you that list of stop talking, that list of external resources. You can find the full video there, so you can watch the whole thing. All right, so moving past him, let's do this last bit. So falling objects. Gravity causes objects to, Carlos, free fall? Neo, what, anybody else have any other, yep, Eunice? Air resistance, Darcy?
To
Projectile, no, yeah, you got Lewis, you're gonna get, oh wait, yeah, all right, so here we go. Causes them to accelerate downward, right? Accelerate, what does it mean? What's acceleration?
Speed up.
Speed, a change in speed,
Or direction.
or both. A change in speed, a change in direction, or both, right? There was a question in the homework about a horse trotting around a ring at the same speed. He's accelerating because he's constantly changing direction, right? All right. So I don't know if that was your homework. I think it was just the other group. Anyway, you might get that question. Remember that. All right. Whereas what acts in the direction opposite the motion? All right, Darcy.
Gravity.
Gravity opposite the motion.
Velocity.
No, good guess, Eunice. Not projectile. So this is gonna be our air resistance. There you go. This is where air resistance comes in. So it's gonna act in the direction opposite the motion and reduce acceleration. So if you have a parachute like this dude's, okay, which isn't very big, but if you have a parachute, it spreads out. Think back to the analogy of the race car and the bus. All right.
That one scene in Despero when he was like, I feel like he had a parachute.
So if you think back to the bus analogy, we talked about how the front end of a MARTA bus is flat and it contacts all of that air. Well, the same thing is happening if you're using a parachute, right? You've got this big material and it's open to contact all the surface area of the air below it, and all that friction is air resistance. So it's going to slow you down. This is also why, you ever seen the squirrel suits that people use? They jump off mountains and do base jumping or sometimes, yeah. So it's like, yeah, like a wingsuit, yeah, so it's like a full body suit, and it has like a fabric from your wrist to your ankle, so when you expand it, you look at the flying squirrel, right? And they will tuck in like this and
Go
point their
faster.
head, and they'll go real fast, because they've reduced all that air resistance, and then as soon as they open up, which I don't know how they do, you think that would be hard with all that air resistance, but they open up and then they can slow down, they can bend their
What if
body
their fabric
forward.
rips or something?
Well, that would be
Okay.
bad. And this is why, I'm pretty sure they have a parachute, because parachuters have two, right? They have their parachute and then they have an emergency chute.
Yeah, like just in case.
And if you've ever watched parachuters deploy a parachute, the first thing that comes out is a little miniature parachute. And its job is to snatch out the bigger parachute. So the mini parachute has enough air resistance to cause enough slowing down of the body falling that's attached to the parachute that it will pull that big parachute out of the bag. Anybody ever seen anybody go skydiving? You ever seen it? Yeah.
Yeah.
My husband did it when he was in college. It scared me to
I
death.
am not going skydiving.
I agree with who said it? What comedian said it? God made perfectly good airplanes and he didn't want us to jump out of them or something like, yeah, something like that. I'm not jumping out of a
I'm gonna
perfectly
do
good
indoor
airplane.
Skydiving though, you know those like.
Yes, actually, we have a
I would
gift
do
card for that. Drew, shut the pantry, please. Yeah, we have a gift card to do that, so I want to do that for sure, because that sounds like fun. You're not gonna like fall to the ground.
Not from the-
There was a guy a couple years ago, they caught on video, who was parachuting, skydiving, and on his way down, he his chute got like tangled, and he was like whipping around, like the guy was being flung everywhere, and he ended up like dragging across the ground. Now talk about friction. Now you don't just have air resistance, but you have like a sliding
There's this
friction
video that if your
with the
parachute doesn't work, or
ground.
the other one doesn't, that you like land on your feet like this.
Crush your legs, man. Ugh, that would just yeah. You do, at least you're coming in at an angle, but this guy gets dragged across the ground and then lifted up again and swung around and dragged across the ground. It looks, he survived it, but it looks amazing.
Well, if your airplane's ever crashing or anything, and there's water, or you can fall in trees with one.
Ooh, water or trees? I would probably want trees, even though it sounds terrible.
Yeah,
Yep.
trees are better because you can plunge to a certain depth of water where you just can't get back up.
Well, that, and when you hit the, everybody ever belly flopped, you know what that's like. Water
Your
has
body
surface
is
tension,
flowing.
right? And you hit it, it's like slap, right? Yeah. There's a comedian, Billy Connolly, he's a Scottish guy, and he did years and years ago, probably 30, 40 years ago, he did a great stand-up routine that's still a classic, where he talked about airplanes and the airplane safety routine that they go through when you get on. And he said, and they tell you stupid things like you missed the buckle, you know, like they talk to you like you're an idiot, is his whole point. And he says, they tell you that there's life vests under your seat, right? And he says, that's so if you crash into a mountain, 1,000 years from now, when archaeologists find you, they'll think there was a river here, which is the joke. You get crashed into a mountain wearing your life vest is not gonna help. You got the next one?
What is whereas?
Whereas, okay, so whereas is a word. It's a weird word. It kind of means what's a good way to put whereas? Oh, it's hard to define.
I thought it was like
Also, sort of like also, or instead, kind of like instead of, or in comparison to is a good way to put it.
I don't know
So you
if
could
I
read
can
this like gravity causes objects to accelerate downward in comparison to air resistance, which acts in the direction. It's sort of like when you're comparing negative things or opposite things. All right, so this last one here. What am I looking for here? Acceleration is 0 and the object continues falling at a constant rate. Okay. Oh, Darcy, go.
Terminal velocity.
Terminal velocity, that's what we're looking for.
Right.
She finally got, I was hoping she would get one right. So
Nothing.
here.
Hold on.
Terminal velocity. Okay, yes. So this is when you are, so when it says acceleration is 0, in this case, it means really that the rate of acceleration is 0. So the rate is 0, meaning that you're no longer speeding up. You've reached the speed at which you're going to continue to fall. But technically, since you're still changing direction, you're accelerating, even though you're no longer changing speed. So that's terminal velocity. So anything that's falling towards Earth is going to reach a terminal velocity, and it's going to accelerate, and then it's not going to a speed where it's not going to fall any faster. It's going to keep falling at that continuous rate. All right, so that's the gravity review, and it's just in time for lab. This is about free fall too. Good. Don't do this to me, computer, internet. There we go.
Good, just right.
All right, that's good enough. Maybe. The internet is just not loving me today. I don't know what's up here. Let me try this again. Okay. Yep. Yep. Come on. Out you go. We'll do this again. Wasting my time, internet. I think we have a bad connection today or something's up. Maybe it's the construction. I can blame the construction, right?
Ooh, that has happened to us like twice. They cut the internet cable fully.
Yep.
And we've had to get the AT&T person over to clear carriage.
Oh my.
You've just thrown a ball and it's travelling upwards. Neglecting air resistance, what force or forces are acting on the ball? A. The upward force from your hand. B. The downward force of gravity. Or C. Both of these.
See.
You can't even see it because
The
it won't go
answer
full screen
is
on me.
just the downward
What
force of
in the
gravity,
world?
which gradually slows the ball, stops it, then brings it back down, making it fall faster and faster. Without gravity and air resistance, the ball would just go on travelling in the direction of your throw. Yes, the ball thrown up in the air comes back. Jump, and you're pulled back to the ground by gravity.
Goodness.
Without the gravitational force, there would be no moons orbiting planets, no planets orbiting stars,
Look at us.
and no stars joining galaxies.
Who's that in the middle?
It's something we discover as babies, and we take it for granted. Famously, the concept of gravity was first proposed by Isaac Newton in the 1680s in his book, Principia, which
Okay, this thing's gonna be funky. So I'm gonna tell you, you should watch it. Just look at the, yeah, but it didn't go. It doesn't do it. It just keeps, see, that's what it, oh!
Oh, yes.
Well, we can watch about 1 more minute of it, but it wasted my time messing up.
law of gravitation. As the legend goes, he was sitting under an apple tree when an apple fell on his head, and he began wondering, what pulled it to the ground? Newton had the idea that gravity acted not just on apples, but also the sun, the moon, and the planets. The force increases as either or both of the masses m1 and m2 increase and drops off by the square of the distance r between them. So, for example, doubling the mass of one of the
There you go. Okay, so finish that at home because it's not playing well and we have to start lab.
A person.
But you know what to do. So, all right, gang. Come on in.
I can't find my lab.
Uh-oh, look for it to find it.